So the last thing we're going to look at in this homework section is solving systems of linear inequalities. This is very similar to solving system of linear equations in that we're trying to find solutions, that is points, that work for both of these inequalities. So when we were solving equations, the solution, we were trying to find the point where they intersect. We said this is a point that is a solution for both inequalities. Well, we're doing a similar thing here, except for we know that with inequalities, we end up shading on one side of the line. So if I have two lines, and I end up shading on either side, what I'm going to be looking for in terms of the solution set is going to be where those two shaded regions actually intersect. So the shared shaded region of the two inequalities. So this is actually not so bad, as long as you remember how to graph and shade inequalities. So let's graph both of these. So we'll create a reference equation for each one, just like before. So this becomes x plus y is equal to 3. This one is 2x plus 3y is equal to 7. Let's put these into slope-intercept form. So to put this one into slope-intercept form, I just need to subtract the x. So this becomes y is equal to negative x plus 3. Here I can subtract the 2x, so 3y is equal to negative 2x plus 7, and then divide everything through by 3. So y is equal to negative 2 over 3 times x plus 7 divided by 3. I'm just going to write this as 2 1/3. Okay, to help me see exactly where it's going to be on my Cartesian plane. Okay. So we want to be relatively neat here because it can get a little sloppy whenever we start shading everywhere. Okay, so the first line, negative x plus 3, so we know that has a y-intercept of 3, and it has a slope of negative 1, so it can go down 1 to the right 1. Again, hopefully this is all review. If you're having trouble remember how to graph, then just check out some of your previous notes, and all of this should be in there. Now, this one references this inequality. It's a strictly greater than inequality, so we know that this is going to be a broken line. The solutions are not going to be on the line. Now here, it's a good idea to go ahead and just label which one this is. Because once we get two lines up here, it gets really easy to get them confused and mixed up and shade on one side of the wrong line. So I just labeled this so I remember which inequality it stands for. The second inequality, let's see, the reference equation has a y-intercept of 2 1/3, so right here. And then a slope of negative 2/3. So we go down 2. We have to be careful. We're on the 1/3 right here. So this is on the 1/3 hash here. 1, 2, and then to the right 3. 1, 2, 3. So you'll see that these actually intersect. Something like this. Okay, so in this case, you can see I have a pretty small area of overlaps. Again, I'm not sure exactly where this point is because my graph is not very well put together. But if you graph this a little neater on some graph paper, then it becomes a lot easier to see. I think I want this to go a little farther down like this. It should intersect at 2, 1 is how I designed it, but I didn't draw the graph very well, so it'll look a little more like this. Okay. I'm actually just really embarrassed of this now, so I'm just going to redraw it. Okay. I can't continue on like that, so just bear with me for a minute. Okay, so 1, 2, 3, 4, 5, 6. the first one, y is equal to negative x plus 3, has an intercept right here at 3, and then a slope of negative 1, so 1. I want to keep going and put another point here. Thanks. And then the second line has a y-intercept at 2 1/3. And then a slope of negative 2/3, so, oops, that should be here. So there's 2 1/3 right here, and then down 2, 1, 2, and then right 3, 1, 2, 3. So this is a little more of what I want it to look like, because I want it to intersect right here at 2, 1, and then we'll just extend this out. But you can still see we're kind of in tight quarters with how close our lines are together, but that's okay. Great, so now what we need to do is just pick a test point like we normally do. So 0, 0 is not on either line, so let's pick 0, 0 as a test point. But I need to test this into both inequalities to see if it works. So let's test 0, 0 into the first inequality. So I'll put in x is equal to 0, y is equal to 0, and I ask myself, is 0 plus 0 bigger than 3? Well, 0 is definitely not bigger than 3. So that tells me that on my first line, which was this one, so again, I should be careful. This is the x plus y is greater than 3. 0, 0 is not included in the solution, so I should not shade on this side of the line. I should instead shade on this side of the line. Now, there's a couple of ways to do this from here. You can either actually just go ahead and shade it, which I'll do right now, or you can just remember that you can kind of mentally remember that, oh, I need a shade on this side of the line. So a lot of times, I'll just kind of draw some arrows like this to remind myself. That way I just don't have shading go all over the place. So I'll do it once where I shade kind of everywhere, and then on the second one I won't do that. Okay. I'll get a nice light shade there so I don't cover up my other line. Now we need to test this point into the solid line to see if we need a shade on this side of the line or on this side of the line, because it's possible now that this region will become our answer, or this small region right here will become our answer. So let's test 0, 0 into the second equation. 2x plus 3y is less than or equal to 7. So 2 times 0 plus 3 times 0, is that less than or equal to 7? Well, is 2 less than or equal to 7? Sure, that is a true statement. So that tells me that in regards to the solid line here, I should shade on the side that includes the 0, 0. So I should shade down this direction. And I've got a second color here. So if I imagine all of this area is going to be shaded now. Now the spot where the yellow and the green, I'm not sure how well the green is showing up on the camera, this is all green and this is all yellow, and the spot where these guys intersect together is actually right here. So that's the region where the two shadings actually intersect each other. And so this is my solution right here. Now you can imagine if you hadn't have actually shaded, if you just drawn the arrows, then you would have been able to kind of deduce that this was the part where they would intersect, and then you could just shade it in from that step. So that's really all there is to it. Basically you do the shadings just like you normally would, but you do it twice, and then find where the two shadings intersect. So let's do one more quick example. So how about 2x minus 3y is less than 11, and then x plus 6y is less than negative 17. Okay. So again, I'll just turn these into reference equations. So 2x minus 3y is equal to 11. And then x plus 6y is equal to negative 17. Let's put these into slope-intercept form. So I can subtract the 2x on this one, so negative 3y is equal to minus 2x plus 11. Then divide by negative 3. So y will be 2/3 x. And then 11 divided by 3 is 3 2/3. So this will be minus 3 2/3. Again, I'm getting some fractions going on. That's okay. Here I can subtract the x, and I end up with 6y is equal to negative x minus 17. Then divide both sides by 6, so y is equal to negative 1/6 x. And then 17 divided by 6, 6 goes into 17 twice with a remainder of 4. So this will be 2 4/6. Oh, sorry, with a remainder of 5, not 4. So 2 5/6. Now, if we do want to find the point where these guys actually intersect, we have methods for that. We could actually find the solution to the system of equations, and we could find the point exactly where they intersect. So if you'd like to do that and get a really accurate graph, that's kind of an extra step that you can take. Find where they intersect by using either the substitution method or the elimination method, and then when you graph it, it'll be nice and accurate. Okay, so let's draw this out. Okay, so the first one has a y-intercept of negative 3 2/3, so 1, 2, 3 2/3 is about right here. And it has a slope of 2/3, so we'll count up 2, again staying in the right part of the hash, so 1, 2, and then to the right 3, so 1, 2, 3, so we get a point right here. Now this one is associated with the first one, it's strictly less than, so this will be a dashed line. Maybe I'll just label this real quick so I remember which one it is. So this is the 2x minus 3y is less than 11, just so I don't forget. And I think I'll use my green for the other lines. This one has a y-intercept of negative 2 5/6, so 1, 2, and 5/6, which is right here. And then it has a slope of negative 1/6, so if I go down 1, and then to the right 6. 1, 2, 3, 4, 5, 6. I'll get a point about right here. Again, this one is also strictly less than, so it becomes a dashed line. It's kind of hard to draw the dashed line straight sometimes, so that's all right. If you have a ruler or a straight edge, it can be a little easier. All right, so again, I need to pick a test point. Since 0, 0 is not on either of the lines, I can pick that as a test point. And again, I'll just go directly into each of these inequalities and see if 0, 0 works. So let's test 0, 0 in the first inequality, so 2x minus 3y is less than 11, and x plus 6y is less than negative 17. So 2 times 0 minus 3 times 0, is that less than 11? So is 0 less than 11? Sure, that one is true. So in my first inequality, the 2x minus 3x is less than 11, which is this line. 0 is true, so we should shade on this side of the line. So instead of shading, I'm just going to write myself some arrows here. This says, yeah, we're going to shade on that side of the line. That way we don't actually have to go through and shade quite as much. Now let's test into the other line. So let's test into x plus 6y is less than negative 17, putting in 0, 0. So this will be 0 plus 6 times 0 is less than negative 17, question mark. So is 0 less than negative 17? No, that's not true. 0 is bigger than negative 17. So that means in comparison to the green line, I should not include the side that includes the 0, 0. I should shade the opposite direction. So on this line, I'll actually shade this direction. Now what you can do at this point is just imagine where would these two shaded regions intersect if I did shade them. So here I would shade all of this area, and then on the green line I would shade all of this area. Well, the only spot that they're actually going to intersect is right in this region right here. These are the spot where the two shaded regions hit each other. So in that case, that becomes my solution. So in other words, all of the points that you pick within this shaded region should be solutions for both of these inequalities. If you pick points that are outside of that region, for example, these points right here, these will be solutions for 2x minus 3y is less than 11. Because we did say that was a solution here. You can see my arrows. All of these are solutions for this particular inequality. However, they will not be solutions for the second inequality. Likewise, if you pick solutions here where that are represented by the x plus 6y is less than 17, x plus 6y is less than negative 17, we said all of these would be solutions. So if you pick anything in this region that's not covered by the yellow arrows, then these would be solutions to the second inequality, but not to the first inequality. Likewise, if you look in this region right here, there's no arrows that go into this region. So if you pick any points in this region, they should be false for both inequalities. Neither one of the inequalities will be true. And then if you pick any points in this particular region, they'll be true for both inequalities. So that's why you always have 4 regions. You always have one region that is true for one inequality and not the other, and then another region that's true for the second inequality, but not the first. And then you'll have another region that is not true for either of the inequalities whenever you pick test values in that region. And then you'll have one region that's, when you pick test values, it's true for both inequalities. And that last region that's true for both, that's the region we consider to be our solution region for these inequalities. So again, we're not adding a whole lot of new material to these. The main thing is just at the very end, after you do the shading, you have to figure out where they would actually intersect together, and that becomes a solution for the system of the inequalities. If you have trouble with this, just doing the graphing, you might want to go back and check out just some of the inequality graphing, and then I think when you come back to this, it will be a lot easier.